All right. For lesson 14, we're looking at an algorithm. We're converting decimals here into decimal division into whole number division, right, by using fractions. And remember, a fraction just means we've got a number on top and a number on bottom. That line in math always means divide, right? So it's the same. Fraction is a division problem. It's just a different way of representing and writing it. And remember, we don't need to draw a tape diagram unless you really want to. You don't have to. And the reason for that is we've learned how it can help support our answers, but that we can also simply write out the algebraic sense of it when we have 1/2 divided by 1 over 10. We know the rule for dividing anything with any kind of fractions. We take any whole numbers, convert them into fractions, right? So we have that fraction section. Then all we're doing is we're going to flip it. We're going to flip the division symbol to a multiplication symbol, and we're going to flip that second number top to bottom, becomes bottom to top. So when we're done, it looks like 1/2. Instead of divide, it's multiply. And then we flip 1 over 10 to be 10 over 1 instead. Now we can at this point cross multiply if you wanted to. We could cross multiply the 10 and the 2, or excuse me, not cross multiply, cross cancel the 10 and the 2. But that's a you decision. In this case, this is simple enough. We could also just multiply straight across. 1 times 10 is 10, and 2 times 1 is 2. And then we would divide here, which would be the same thing if we did this cross-canceling chunk here. So we can divide both these by 2. 2 divided by 2 is 1, and 10 divided by 2 is 5. And you'll see why in a second that would be the same thing. I would get up top here, I'd get 1 times 5 is 5, and 1 times 1 on the bottom is 1. My answer should be 5 over 1 or 5. And if we look here, I have 10 divided by 2, which the answer is 5 over 1, or 5 wholes. Okay, so we're going to use this information going forward for today's lesson. So as we evaluate this expression, it says use a tape diagram to support your answer. Like I said, you don't have to unless you want to. In this case, what it's saying is 0.5 is 0.1 of something divided by 0.1. So in other words, what that's saying is if I do something here, this would be 0.5, and that represents 0.1, or if we were to change these into fractions, 0.5 is 1/2, and then 0.1 is 1/10, right? So this would mean this is 1 out of 10 things on a tape diagram, just showing a descriptor here. So this would be 2, this would be 3, 4, 5, 6, 7, 8, 9, and 10. And each one of those would be 0.5, 0.5, and so on, right? So we can rewrite this as a fraction when we look at it as, remember, 0.5, we said it's 1/2, but we can also look at it this way. So we have on this hand, we have 1/2 divided by 1 over 10, which we did earlier, so we're familiar with that information. And so we already have our answer, right? The answer we did earlier on the front page was that it was 5 wholes. And if we look at it, right, 0.5 and 0.5, that's one whole. 0.5 and 0.5, that's another whole. 0.5 and 0.5, 0.5 and 0.5, 0.5 and 0.5. I see 5 of those loops, so it should be 5 wholes. But we can also rewrite this as a fraction where, again, we just take the top number. We take the first number and we put it on top. We take the second number and we put it on bottom, right? And then what we can do is says express the divisor as a whole number. So what we're doing is we're changing these into whole numbers. Well, if we look at this, this is the same thing as if I were to multiply the top by 10 and multiply the bottom by 10. Anytime that I multiply something by one number over itself, so like 5 divided by 5, right, or like 8 over 8, all of these still equal 1 because 8 divided by 8 is 1. 5 divided by, remember that line in math means divide. 5 divided by 5 is 1. So 10 divided by 10 is still 1. When you multiply something by 1, it doesn't change the actual answer. It just changes the way that it looks, right, when we multiply it by a fraction. So if I multiply the top and the bottom by 10, remember my trick about multiplying tens? All you do is every time you multiply something by 10, you move the decimal one space, and it's one space for each 0 as long as there's a 1 in front. So if you did it times 10, you'd move the decimal 1 space. If you did it times 100, you'd move the decimal 2 spaces. If you did it times 10,000, you'd move the decimal, count the zeros, 4 spaces. So in this case, I'm going to move the decimal 1 space on the top and 1 space on the bottom, moving to the right. So here and here, I get 5 over 1, which is that answer we talked about from before, which was 5. Okay, So we're going to continue to do that process throughout this lesson. All we're doing is we're taking decimal numbers and converting them into whole digit numbers to then divide by. So if you look at this first one, it says convert decimal division expression to fractional division expression in order to create whole number divisors. That's a fancy way of saying take what this is, turn it into a fraction, and then find a multiplier. Remember, the top and bottom numbers have to match, so 10 and 10, so that we get whole numbers, or we get rid of these decimals here and here, right? And then explain what you did. So in this case, it says I multiplied both dividend and divisor, or the same as saying the top and the bottom, right, by 10, or by 1 power of 10. So each decimal point moved one space to the right, and it grew larger by 10, like we talked about on that last thing a moment ago, right? Every time that you multiply it by a 1 and zeros, all that does is move the decimal, and you count the number of zeros, and that's the number of spaces you move to the right. So as we look at the second problem, we're going to first convert it to the fraction, 14.04 over 4.68. You'll notice both of these need to move the decimal 2 spaces to get whole numbers and not fractions, 1, 2, right? So what we're going to do is we're going to multiply it by not 10, because that would move it 1 space. We need to move it 2 spaces, so 100. Whatever we do on the top, we need to do on the bottom. 100 divided by 100 is still 1. When we multiply something by 1, it doesn't change. We just change the way that it looks. So my new answer now is going to be 1404, or 14,004, divided by 468. And this would give us the exact same answer as using the decimals here, but just without any decimals, using whole numbers now. Right? And so what did we do? We multiplied top and bottom by 100 to move the decimal 2 spaces right, which gave us whole numbers. All right, let's look at this next one. So again, we're going to convert it. So I have 0.162 divided by 0.036. We can see I'm going to need to move it 3 spaces. 1, 2, 3 down here, and 1, 2, hang on. 1, 2, 1, 2, 3 spaces. Sorry, my computer's a little off here. That way. So we're going to multiply each of those by 1,000, 3 decimal places, right? 3 zeros, so move it 3 spaces. And we'll end up with 162 divided by 36. And same thing as up above, just instead of multiplying it by 100, top and bottom by 100, we multiply top and bottom by 1,000. So multiply top and bottom by 1,000 to move the decimal 3 spaces, because it was 3 spaces, right, for a decimal, 3 spaces right, to then get whole numbers. Okay? So continuing on, same basic concept. We're going to turn this into a fraction first. So I have 25.2 over 0.72. Now you'll notice here is just 1 space, and here is 2 spaces. Now we cannot do 1 space on the top and 2 spaces on the bottom. When we multiply something by different numbers, now we're actually changing the answer. So we're looking for which one do we need to do to make sure that there's no decimals. If I only move it 1 space on the bottom, it goes to here and it becomes 7.2, which still gives us the decimal. So we go with whichever one has the most number of decimal spaces to move. That's the bottom, 100. So we do the top, 100. And now if we did multiply it by 100 over 100, that doesn't change anything except how many spaces we move on the top. But that keeps everything else the same because it's 1. 100 divided by 100 is 1. So I get 2, 5, 2. And then you notice how there's this blank space here? We're just going to fill that in with a 0. So 2,520 divided by 72 would be our answer for that. Okay, and says to use the algorithm for the quotient. Again, keep in mind, all we're looking for is an approximation on this. So I'm going to round 2,520 to 2,500 over, let's say, 70. I'm going to round that down. Remember, I rounded both of these down a little bit, right? I can cross those, the 0 and the 0 out. I'm left with 250 over 7. 7 goes into 25 3 times, right, with a remainder 250 3 times, that's 21 with a remainder of 4. 40, 7 goes into 40 5 times with a remainder, right? So we're looking at somewhere around 35, 36 times, something like that. And we can actually use our calculator to come up with the exact answer. And so 2,520 divided by 72 is actually, it ends up being exactly 35. So we got pretty close with our estimation. And because we ended up rounding each of these down, that's where we were able to do it and come up with the correct answer. So that the exact answer just happens to be 35. It's not always going to be that case, but in either case, it would have been close, right? Okay, looking at these exercises here, same thing is true. All we're going to do is we're going to change it so that we've got stuff set up to create our whole numbers, 3.2. So in this case, we would multiply each of these by 10, 10 over 10, right? We'd get 2, 0, 0, 0, and you see how so that's 2,000, then we multiply by 10, so we'd add a 0, and 33.2 times 10 would be 32, right? This next would be 358 1.9 over 4.9. Each of these cases we're moving at one space, right? One space and one space, so 10 and 35819 over 49. 893.76 over 0.21. In each case, we see we have to move it two spaces. So it should be 100. There's my two zeros. And it's going to be 89376 over 21. And the last one, 6.194 over 0.326. We'll notice in each case it's 3 decimal places. So we're going to need to multiply by 1 and 3 zeros, or 1,000. And we get 6194 over 326. And then using our calculators, we're going to go ahead and just do the math on that. So I have 20,000 divided by 32 is exactly 625. And I have 35,819 divided by 49 is exactly 731. And 89,376 divided by 21 is exactly 4,256. And my last one here, 6,194 divided by 326 is exactly 19. Looking at these next ones, it's now taking some information from a problem, a word problem, and just putting it in. So plane travels that amount of miles in that amount of hours. What's its unit rate or its speed? Right, so we're going to start by doing a fraction on this. We're going to represent that as 3,625.26 over 6.9. We need to move the bottom one space. We need to move the top one 2 spaces. So we need to move both of them 2 spaces. So that's the 100. 3,625.26 over 690, right? So we're going to estimate the quotient here, right? 36,000 or 362,000, 526 divided by 690. I'm going to round 362,500 to 363,000 over, I'm going to round 690 to 700. Let's round it to 1,000. It's going to be way off compared to whatever, but it'll be easy for math-wise on this. We see we can cross out some zeros here. And I'm left with 363 roughly. 363 roughly. We're going to now go ahead and we did, so this part is here with the whole number, right? Represent it using the units here. That's the division setting up as a fraction. Use algorithm in this case. Like I said, all we're going to do is we're just going to use our calculator for this because algorithm, we know how to do it. And so then it's just a matter of spending the time to work it out. Or like I said in my class, I'd rather that you spend the energy and effort working out the hard problems and setting everything up as opposed to that. So 362,526 divided by 690 is 525.4. And if you notice, why are these so wildly off? They're off because we ended up going from 690, right, this number here, to 1,000. So we rounded it way up. If we had instead, and so when we round the bottom number up, that means we're going to be super low. If we had instead gone 363 divided by, rounded it to like 700, we'd have these ones here that'd be zeros, and then we'd get 3,630 over 7, which then just becomes like, we could do it, it just becomes more work as far as putting stuff in and doing long division on this, like mentally. So we know that 7 goes into 36 5 times, that's 35, right? And then we have a 1 and a 3, we know that's a 1, we know that that's a 6, and 7 goes into 60 8 times. That gives us 56. And we notice that this answer here, which is still an approximation, is a heck of a lot closer to that. We're trying to get in the ballpark, whether we're talking about ones, tens, hundreds, thousands, and so on. So that's where we went with the shorter thing here of this 363. Okay? And with that, we are on to problem set.